Hello, everyone. Welcome. Good to see you all coming into this webinar. We'll wait just a couple more minutes. We see a lot of people joining. So we'll wait a couple more minutes, right?
Yes.
To see if everyone's there. Hello, everyone. Good to see you all joining today's webinar. All right. Shall we kick off?
Yeah, let's just wait for a second.
Yeah, more? Okay. We'll give you more minutes. Okay. I think we're good to go, right?
Yeah, let's start.
All right. Well, welcome. Thank you all very much for joining today's webinar. Let's do a quick introduction of who we are, who's attending this webinar. So my name is Maud, and I'm part of the sales team here at Siebe Construction.
My name is Jesse, Learning and Development Manager at Siebe Construction.
So we're very happy to tell you today about this webinar. And this webinar will also be available on demand on our library platform. So make sure that you subscribe to the library to get informed about all our coming webinars as well. If during this webinar there will be any questions, please feel free to ask them in the chat. We have our moderator, Pleun, here today with us. She will answer all the questions. But of course, there's also room for other questions at the end of this webinar during the Q&A. So if you want to wait until that moment, that's fine as well. The subjects of the next webinars in the future are also listed here on the page. So make sure that you will be attending these as well if this is of interest to you. The next webinar we will be hosting will be with one of our partners in New Zealand, which is Cox. And this will be next month. So we would be happy to see you there as well. All right, we're very curious who is all attending. So maybe it's fun to see the different continents you're from. There will pop up a poll here down below. So if you can vote from which continent you're watching the webinar, it would be nice to see. I guess that for a couple of you, maybe it's in the morning. Over here, it's in the afternoon. So we're curious to see who is attending. A lot from North America, Europe. All right. Good morning. Asia as well. Okay, not many people from Africa, Antarctica, not yet. Okay, cool. Thank you very much for voting. Good to see you all. So of course, most importantly, what is the learning objective of today's webinar? So the learning objective is to get a proper understanding of which type of 3D concrete printer would be most suitable in construction projects. And this is important to get the full potential out of the machine. As we are aware that there are a lot of different machines present in the industry, and they're focused on different type of industries as well. But for today's webinar, we will be focusing on the housing and residential buildings. And we do this for our selected 3D printers, which will be the Siebe Robotic Crawler and the Siebe Gantry System. We will start with a quick introduction about the development of these systems, how we got started, etc. And that will be based on the Robotic Crawler and the Gantry System. And we will explain this by means of a user's case.
So first, to begin, we start with an introduction of Siebe Construction. So where we're coming from and where we are now at the moment. It started all in 2013 with the founding of Siebe Construction. Our CEO, Barry Hendricks, worked at the construction company at his family, and he had a lot of problems, like the housing problem, shortage of labor and skilled workers. So he searched for solutions, and that's when Siebe got founded. So from then on, we started with learning by doing, and started with prototyping in 2014. In 2014, we developed our own material and also our technology. In 2015, we started with the design and engineering of our robotic arm and also of our gantry system. So that was a very intensive year. And so in 2016, we chose to focus more on our robotic arm because Barry at that time saw that a mobile printing device was the right solution for the problems at that time. So in 2017, we developed a product and we gave the demo in which we demonstrated to the world that we could print with our robotic arm. And that was also the world's first on-site printing house, 3D printed house. So after that, we started working to achieve building more sustainable, faster, and also cheaper, because only by doing that we can change the world of construction. In 2019, we started with designing our Live label, which our in-house architects developed easy to build houses for our 3D printers. So specifically houses that could be printed with our technology. In 2020, we pursued our design engineering of our Gantry system because we found that the market was searching for more solutions to build more effective. So we started with the design engineering of our Gantry system again. And so last year, the design was done, and we could start with prototyping the system and with working with it. So we can we can build faster, cheaper with different systems. And that's what we are going to explain in this webinar, how to build it and in which case, which technology you can use. So our mission and our vision, we strive to solve problems in the construction, like the reduction of CO2, the housing shortage, and also the shortage of skilled labor. And we do this with a global and holistic way. Only with high tech and automatization, we can build faster and more sustainable, and also more affordable. So only by striving to this with a mission of working globally, we can fix the worldwide problems, and not only in our own region, in the Netherlands, for example, but worldwide. So how can we do this? We do this with the three ways: building faster, which means building faster with our printers, printing on a speed of 500 meters per second. Also, like our walls can be hoisted after 24 hours. So it all reduces the time of the construction. So building faster means automatically also more affordable, because when printing on site, if you can print with a reduction of time, you have less overhead costs, like rent of fences or other overhead costs. Also less labor costs, because our robotic arm can be operated with 2 persons, also the Gantry system. So that's a reduction of labor costs. Furthermore, also building like more houses in the same time, so you have more houses that are finished, and that's more. So you have more profit. And the last one, we're trying to build more sustainable. So we do that with our own material that has a reduction during the production of 32% of construction. Of CO2. Furthermore, we can print our own formworks, but there's a less waste of materials of, for example, wooden formworks. So what we have done today. In this map, you can see an overview of all our projects, and also our where we have sold our printers. And what we're doing is not only selling a printer, but we're building a sustainable relationship with our partners worldwide. So when you are buying a printer with us, we support you with providing design engineering, or for example, the design of your house, also the support of material development. And also, help you with your projects worldwide.
So now we'll first start by explaining the robotic crawler that we as SIBA have developed. So we'll start with the basic, the specifications of this type of 3D printer. It all starts with, we're gonna have to start with a poll first, because of course we want to know what your level of experience first is with a robotic crawler. So if you want to fill in down in the poll below, how do you estimate your level of experience with robotic crawler? This can either be the knowledge that you already have, or maybe you've already put it into practice. So we're very curious how much you have experimented with robotic crawler already. So please fill in the poll below. Let's see if we can see the answers. All right. Okay, good to see. Most of you still novice, but also some of you advanced or competent. Very well. Good to see. Proficient as well. All right, great. Good to see. Well, I hope we can still tell a lot of new things to you. So we will first start with the specifications, of course. So the SIBA robotic crawler is built up into two systems. Basically, we have the hardware and we have the software. So the hardware entails the ABB robotic arm, as you can see on the picture. We have the mixing pump system, which is very important for the material. Underneath the robotic arm is the mobile crawler, which allows you to use the crawler in a mobile way. And of course, the control unit with which you can control the machine itself. On top of that, we have our in-house developed software, which is SIBA Chisel, with which you can slice 3D designs, which makes it able to make a toolpath which is understandable by the robotic arm. So then the arm will know which toolpath to use. And we have SIBA Artisan, in which you can see the print statistics. So you have to think of this as like the material, the other statistics of which will be from the mixing pump system. So the humidity, the temperatures, etc. But you can also control the robot by means of this software. So it's a very important one. And on top of that, there are some additional options. These additional options, they will be relevant based on the type of projects that you will be printing. So this is basically adjustable for each company, which will require this option, yes or no. Overall, the options that we have are on the mixing pump system, which is an automatic startup system, which reduces the number of people that are required, for example, for the setup of the material, which is quite an important part because you want to have all the variables right in order to start up the printing procedure as quick as possible. We have the self-leveling option for the crawler. So this will mean that the machine will level itself, so it will not have to be done manually. And we have height control, which is very interesting if you want to print, for example, very high elements, as you can extend this from 3.2 meters up to 4.2 meters. And we have the option of a rotating nozzle, which can be used if you want to print a different type of, for example, of elements in which you can play a bit more with the software. So these are basically the more general specifications of the printer. But maybe what is more interesting to see is the speed that we can print with our robotic crawler. Because what we think is Sorry, I think the sound just got cut off, but what you just saw was a video of one of the projects that we've been printing. So this is one of the wall elements. So what is very important about the strategy that we use with the robotic crawler is that we can print at a very high speed due to our material. We can print at a printing speed of 500 millimeters per second, as we have developed a material which sets in 3 to 5 minutes. So we've done this together with our partner Corridor, which is a German company. And in 2013, we have developed the material which allows us to print at this speed. So we have a different video as well, which also shows you the speed that we've printing. Within that, you can also see the way we construct a wall element by placing the reinforcement elements already into the wall by printing, which reduces the time that it needs afterwards. So we'll look at this video as well. So this was one of the wall elements that we printed in a project during a project in France. And as you can see, the printing speed, it's very fast. So this allows us to print wall elements in 2 to 3 hours. So for this reason, it's also able to construct a whole building within only a couple of days. So what is the range like of a robotic arm? We receive a lot of questions how to visualize the range of a robotic arm. So you can see here in the building, it's like a donut form. And the printing range is 5 meters to 3.5 meters. And this is possible because within our software Chisel, we have the printing on an angle possibility, which basically allows the robotic arm to print instead of this on like an angle. So it can reach the corners, which allows the print operator to reach a different angle and a longer extendable reach for example, longer wall elements. And also with the height control option, this is the extendable option by means of height. So you can print higher elements if that is required. This is the other option that allows us by having a material which is fast setting. So this is a very important part that we have developed. As Jesse mentioned, also the elements can be hoisted after 24 hours. So this allows you to keep up the speed and the pace of producing the wall elements. The layers that we print with the robotic crawler is variable. So you can print at a height of a minimum of 10 millimeters up to 20 millimeters. And we see that the perfect average is 12.5 to have the perfect consistency of the layers. The width will be around 40 millimeters to 35 millimeters. This is depending on the nozzle that you use, but we most frequently use the 40 millimeters nozzle as this gives you the perfect layer outcome. The number of axes on the robotic crawler is 6, but if you use the height option, this will be 7. And in the end, what is very important about the robotic arm is that it allows you a lot of design freedom. So very complex textures can be printed as the preciseness of the robotic arm in combination with our fast setting material allows us to print a lot of different designs and textures without using extra amounts of material. So what you can see here is maybe good to visualize what we mean by the height control option. So we're going to look at a video in which you can see that we're printing an element. And if you can see in the white round, you can see that the level of the crawler, so the crawler itself, is extending during the print. So we're going to take a look at that. Okay, so we also have a different video in which you can see the printer itself extending. So we'll take a look at that as well. Video was speed up because the printing arm was going very fast. But in general, it's a speed of a bit slower, so don't worry. So for the robotic crawler, the pricing is starting from 195,000 euros. And based on the experience that we have had with the different type of usages for the robotic crawler, we have developed different packages. And what we want to reach with this package is that it's easy for our customers to know what needs they have, as the additional options that we offer can give some questions. So if we have divided this into 3 packages, the basic, the Pro, and the Pro Plus. And basically what we have in the Pro Plus is all the options that we have. So if you want to have the full efficiency and the full easiness of using the machine, such as the automatic startup, this includes the height control, the self-leveling option as well. That's when we advise the Pro Plus. But of course, also, if height control is not a necessary option, if you only want to print wall elements from, let's say, 2.8 meters height, then the Pro is a perfect package for you to choose. And the basic is all the basics that are included. So then you should think of the robotic crawler with the necessities, so the mixing pump system, the software that we include. We included training as well, because this is always something that we think is very important. So this is always included from our side. And of course, the service level agreement that we have is also always included, as we want to make sure that we can guide our customers through the printing process. So this is basically how it's divided into the pricing for the robotic crawler. What is important for the robotic crawler is the printing strategy that will be used. So for example, you can print with this system on multiple locations. You can print on-site, you can print as precast, you can also print as semi-precast. And the main differences between precast and semi-precast is that precast will be done in a factory. So it's a controlled environment. It can have a production ongoing process. And semi-precast is when you have a deliberate location, for example, on a construction site, that you will be producing the elements on. And then further from that point, you will be hoisting the elements into the final location. So what you can see is the setup time of printing on-site will be 45 minutes approximately. This is due to the fact that you will have to make sure that the machine is well leveled, that you have the right variables all available for you to set up the machine and start printing. So loading it from the let's say from the truck, for example, until startup time is approximately 45 minutes. Whereas when you're going to start printing on, for example, precast, this can be done easily within 15 minutes, as the setup time is not that much due to the fact that it's placed on a set location, so you can keep on the process of printing.
Yeah, so what we are thinking is that the overall equipment effectiveness is really important for us, because it gives us an insight about our efficiency of the printing strategy. We want that our printers are printing as much as possible, and that's only possible when our printing is done without a lot of time of setup and also disassembly. Yeah, one of the key factors of the overall equipment effectiveness is the low setup time, which increases the availability of the printer itself. And because our crawler system is a mobile and flexible system, the setup time is really low compared to the printing time, and so you have a high overall effectiveness overall. Yeah, by printing a lot and also with a less setup time, our partners have a faster return on investment. So this overall effectiveness is important for our crawler, but also for our Gantry system. Yeah, so that's it. and which the effectiveness is important. So the printing strategy that we will choose is a strategy in which we can print the most of the times with our printer. In this image, you have loops of 5 weeks, and in every loop, something is done in construction. When we want to print on-site with our printer, we can build a house in only 5 weeks. This means in the first week that you can prepare the construction site and also building the floor slab. And after the second week, or in the second week, you can print 1 week. After that, in week 3, 4, and 5, house 1 is getting finished. But you don't have to wait for the printer, because you can just drive the printer away to the second house, and in week 3 you can also already print house 2. So this means that your printer, your coder, is only printing 1 week and is driving from one house to another house without having the high setup time. So printing with a coder on site is a very effective strategy, because you have the equipment effectiveness is high. You can also print with our printer offsite, so in a production facility. In fact, the strategy will be the same, because the printing time itself won't differ. So if you have 1 week of printing time on site, you have also one day of printing time offsite. The only thing is that you are going to hoist the elements to the construction site, so you have to do with transportation, but the printing time itself won't differ that much. So the strategy for on-site or off-site for a robotic coder would not differ. So there was a small introduction about the overall effectiveness of our equipment. So we have a poll. Do you now have a proper understanding of the importance of the overall effectiveness in the 3D construction printing industry? You can fill in the poll below. Okay, so it's 50-50. Later in this webinar, we'll discuss the overall effectiveness of a gantry system. And if you have any further questions about the effectiveness and why it's important, just ask them in the Q&A, and we will answer the questions about the importance of the overall effectiveness. So feel free to answer those questions. So we explained about our gantry our coder system, and how you can use it, and also what is the printing strategy. And then the next part will focus on a gantry system, how to use it, and what's what the pros and the cons are. So a gantry system, we built it with Z columns, X and Y beams, and also some elements are quite the same for Robotic Arm as a coder system. So like you have like a print head, also the mixing pump system is the same. And also, for example, our coder system will be used with our own software, the Chisel software and the Artisan software, which Maud explained. So if you want to use a robotic arm, or you want to use a gantry system, controlling our technology will be the same for both systems. So if you want to change for a system in the future, you don't need a lot of new training about how to control it, because the software will all be the same. We have also an option for our gantry system. That's ABB robotic arm is attached to the gantry system to give also the flexibility on a gantry system as you have on a robotic arm for example, making the designs, and also the new free forms that you can have with a robotic arm. So we now have a video of our gantry system, so you can see how our gantry is moving, and later in the webinar, we have also a video of how our gantry is printing. So in this video, you saw our gantry system moving. The speed of our system is the same as for robotic arm, so it's 500 millimeters per second, which is it's really fast. It's a really fast gantry system. The printing range of the print itself starts with the standard dimensions of 7 by 10 by 4 meters. With that dimensions, you can print our lift designs that are available, and you can download them on our library. The range itself can be, and the dimension of the gantry system can be extended to the needs of our clients. So if you need a larger gantry system, we can. It's a modular system, so we can expand the dimensions of it. Our material that we use is slightly different than our standard robotic color system material. So we have a material that has a higher curing time of about 20 to 30 minutes. Because of the toolpath of the gantry is longer, it needs more time for the setting time, because when we are printing, we always want our layers printed wet on wet. So you have a solid block of concrete, and it's only possible when you have like the curing time of 20 to 30 minutes with our gantry system. The layer specifications are also like 40 millimeters width, and that means that compared with all walls of, for example, 70 or 80 millimeters, you have a reduction of half of the materials, and only with the technique, with the infill technique, you have a reduction of material, which also means a reduction of CO2. So that's and also this is not very different for a robotic crawler system or a gantry system. It has all the same width, and so the same reduction of materials used. So the number of axes is 4 axes, but with the option with the ABB robotic arm, these axes can be extended for the form-free designs. So we have now a video of our gantry printing. I'm sorry, I think we have some difficulties with the technology. So if you are interested in this video, please contact us on our email, so we can show you the video. No, excuse me, it won't work. So if you're interested in the technology, please contact us so you can see the video of the gantry is printing. So the gantry system, it can be the gantry system can be placed also on multiple locations. So it can be set on site, on the construction site, or precast off-site. It also can be used for printing, for example, foundations of formworks. In which you have a reduction of materials, because you don't have the wooden formwork. It's just of concrete, so that means less waste of materials. For the facilities that you have that you need for on-site printing is you need a heavy crane, because the elements of a gantry system are heavier compared to the robotic arm. So you have you need stronger hoisting materials, for example, or a heavy crane. So for the overall equipment effectiveness of a gantry system, it depends on how you on your printing strategy. If you want to use your gantry on site, you have less printing time. So that means that you can print, for example, for 1 week. But if you will print 1 week, you have to before you can print, you have to assemble the printer itself, and that will also cost 1 week for assembly. And also after printing for 1 week, you can disassemble the printer, and that will also take 1 week. So that means that your equipment is less effectiveness, because the printing time, the percentage of the printing time is, for example, 30% if you have 1 week of assembly, 1 week disassembly, and 1 week of printing. For precast, it's another printing strategy, and for modular construction, you can raise the effectiveness. So that means that by another printing strategy, you can your printer can print more time. So and more printing times means more elements, for example, that can be built. So the effectiveness, in this example, you have also loops for construction of the same house. And what you can see here is like the construction that is normally can be done in 5 weeks. So in the first week, you have also the construction of the floor slab. But if you're printing on site, you have in the second week, you have to work on the assembly of the printer itself. It will take approximately like one week. So that means that in the third week, you're ready to print. The printing time will not be different, because you can still print with 500 millimeters per second. So the printing time will also be 1 week. And after that printing time, you need also a week for disassembly. And that means that your printer is standing still for 2 weeks in this situation. And after week 4, the building can be finished. So the roof, water installations can be fitted in. And the printer is disassembled, so can move to the next project. And that could, so the same loops will be there for the house too. So in this situation for on-site printing, the printer is standing still for is printing less time, but we were thinking that the printing time is really important. So we think that the printer has when it can be effective, and you will print a lot of elements. You don't want that disassembly and assembly time. So the printing strategy for on-site, for example, a multi-story building, will be also the same. So you have also the times between, because you still have the assembly of the printer. But what you here have is like if you have printed the first floor, you will make the floor slab, but you have also the curing time. So you have to wait for the curing time of the floor slab before you can print the next layer. So for the second floor, you have also the printer standing still and is waiting for the floor to cure. And after 2 weeks, you can start printing again. And for the third floor, the same story. We think if you will, what an effective printing strategy is, that will be using the Gantry system offsite. So that means that you have still the printing time of a week, but if you can move the elements away of your facility, you don't have the assembly and the disassembly time of your Gantry system. So that means the first week, the printer of the floor slab of the first house can be done. In the second week, the elements can be printed and hoisted to the location. And in the third week, the house can be done, finished, and the printer is in the third week already printing for the second house, and so on. So it's a big difference of the printing effectiveness of off-site printing or on-site printing for a Gantry system. So that's really important to keep that in mind. When using a Gantry system. So we have a poll. We are wondering if you were purchasing a 3D concrete printing system, what factors of buying a gantry would be important for you? And you can fill in the poll below. And if you fill in other factors, we are really wondering what those other factors are. So yeah, feel free to share with us in the chat. I see that the possibility to construct multiple-story buildings is really important for you, and also the possibility for high effectiveness for on-site construction. That's an important factor, Kevin, indeed. So the factor of training and support is really important for purchasing a printer, but that won't, for us, it won't be different for buying a printer for example, the Robotic Arm or Gantry System. So the support will be, yeah, that's a really important thing for us. So but it's a good answer. So the similarities. We now have presented the two systems, like the color system and also the Gantry system. You have some similarities and also some differences. So that will present.
We'll explain that. Yeah. So regarding the comparison to traditional construction, it is all the same. However, this is based on the user's case that you will be using the system for. So either the robotic crawler and the gantry can produce housing projects faster, cheaper, and more sustainable compared to traditional construction. But as we mentioned earlier as well, this is all very important based on the printing strategy that will be used. Also regarding the hardware, it's basically more or less the same, only the system itself, whereas the robotic crawler is way more mobile and smaller, and the gantry system is way larger, so it's a different type of using the technology. But the way we present it, it's all the same in terms of the control unit works the same. It's more or less the same mixing pump system, some additional features on it to make the process of printing with the gantry system more easy. But in general, it requires the same hardware to be used as an additional part. Software, as Jesse mentioned, we also use the same type of software for either the robotic crawler as the gantry. So there will be no differences in this way to operate both machines. It will be using the same software. Regarding the material, it is the same compound. However, the layers, the setup time is different, as mentioned. But the compound and the way it is constructed together, it's the same. It also allows you the option to use less material compared to other ways of printing, as we print with the 20 millimeter layer width. So this is both the same for the robotic crawler as the gantry, same as the compound, which is cement, sand, water, and additive as well. On top of that, we have the, let's see, the number of operators that is required. So it's a minimum of 2, and depending on the complexity of the print, and of course the type of experience printing with both systems, this could help. For example, in the beginning, you might want to start with 3 operators if you have more complex designs, whereas when you're a bit further in the process, you can easily do this by only 2 people. So overall, they also have a lot of similarities, the robotic crawler and the gantry. And of course, the similarities and the uses of the technology is very much based on the use case that you will be choosing for. So the differences. What is very important is that the differences between the robotic crawler and the gantry is the print range. And for this print range, you want to know what type of projects you want to be printing. So for the robotic crawler, we have a print range of 5 meters by 3.5 meters. So what is important in this case is that you will be printing wall elements. So the construction of a building will be divided in different wall elements, which can be hoisted and attached on the construction site. Whereas with the gantry system, you can print, for example, modules. And these modules can be either printed on site or off site. but these are complete modules that are printing instead of the elements of walls. For the gantry systems, we use 10 by 7 by 4 meters as a standard, whereas we have different options as it is a modular system. So if any added sizes are required, this is a possibility as well. And for the robotic crawler, it's just one option. So we can print up to 5 to 3.5 when the height control option is chosen, 4.2 meters. And for the gantry system, you have more, you can play a bit more with the sizes. Regarding the material, as I mentioned, the setting time is a bit longer as the tool path of the gantry system is also a bit longer, so it requires a longer setting time. And for the, let's say, the efficiency of the printing strategy, as mentioned, with the robotic crawler, you can print both on-site and off-site, whereas with the gantry, we advise to not print. Oh, I see that the boxes are not correct. You can print on-site and off-site, whereas we advise to only print off-site with the gantry system, as this allows you to achieve a higher overall equipment effectiveness. So this is very important, but based on the user's case we will be explaining later, this will become a bit more clear. And of course, the design freedom. The complex textures are a lot more easy to create with robotic crawler, as with the gantry, as this is a very larger system, so it's more difficult to create very complex designs and different textures. But with the option of choosing the gantry with a robotic arm, this allows you to create more form freedom and textures. So how to choose? And what we want to achieve with this webinar is not by only telling you what the differences are between a crawler and a gantry, but also enlightening you about the influencing factors which are very important to take into account when choosing for either a gantry system or a robotic crawler system. So this, for example, starts with the type of building. If you want to print one-story buildings, or if you want to print two-story or multi-story buildings, this is a very important factor. Also, the number of buildings that will be printed within one project is depending on the overall equipment effectiveness of the machine. Another decision that will have to be made if you want to have a printing strategy of building on-site or off-site, and if you are printing the distance to the project as well, as this all has to be taken into account of the overall equipment effectiveness. Because once again, the overall equipment effectiveness means that you want to achieve the most efficientness out of your machines. And your machine will only be very efficient if it's operating and if it's producing, for example, wall elements or modular houses. And not only that, but also the country or regions that you will be printing in is very important. So this can, for example, be the construction regulations that account in this place, but also if it's a very dense country or an outstretched country, and this will then all depend on the type of buildings that you will be printing. So we do not want to say you have to choose for a gantry system or you have to choose for a robotic crawler, because we believe that this will be based on the printing strategy that you will be using, which is influenced by all these factors.
So we have two cases for today in which we give you an example of in which situation you should choose for a crawler system or a gantry system, and what system is the most effective. So for the first case, we give you the example of a single-story building. We built it in Curaçao voor a betonbrievengat, and it's called a Robust Villa. So this is especially designed for one story, and we calculated that the printing time should be 1 week. Total construction of 5 weeks. We calculated this with the loops. So we calculated for 5 weeks construction and 1 week of printing time. We built 1 week, but we prepared it that you could print it multiple houses with an efficient printing strategy. In this situation, we printed it off-site, but it was also be possible to print it on-site. And so you have for the 1 week of floor slabs, printing 1 week, and after the 1 week of printing, the printer could be driven to the second house for printing there. With this, we could reduce the time of the construction from 25 weeks to 5 weeks. So that means faster construction, also faster, cheaper construction. So for the conclusion of the robust villa, in this case, for the one-story single house, the crawler system was a very effective printer with a high overall equipment effectiveness. In this situation, we choose to print with the crawler. So for the second case, we have our Marco Polo project. And the Marco Polo project will also print 3 row houses in Eindhoven, Netherlands. And it gives an example of how to print a multiple story building. And for this project, we think it's a more effectiveness to print it with a gantry system, but not printing it on site, but printing it off site in our production facility. So because we can print it in our production facility, we can do it on a modular way, and we can use our printer for only printing, and not have not to take into account the assembly and disassembly time. So here you can see the principles of the house. We are going to the concept of these houses in the upcoming webinar in December. And these houses, this is a multiple story building, but it could be also for higher buildings. So for example, apartments. So for the Marco Polo project, in this situation, the 2-story single house was more effective for a gantry system than for a crawler. So more about the technology of the Marco Polo project in the next webinars. So we're wondering about your opinion. So do you think will there be more on-site or off-site printing in the future? And I see that we have only 5 minutes left for today. So I think we will go soon to the Q&A for today.
So what you see in this case is that the equipment that you will be using will also very much depend on the design that you will be printing. So in this case, we have developed for each type of system the own housing concept as well. So the robust villa design that you saw for the robotic crawler is designed in a different way than the concepts that we will be using for the gantry system. And because we want to provide all-in-one solution, these are the designs that we also provide on our library platform, so that we can guide our customers by creating ready-to-print designs in this case. So we can do the design and engineering, and these can be retrieved from this online platform so that it's ready to be printed. And besides that, we also guide customers through the design and engineering process. So we see that that is a very important factor as well. Okay.
So for the results in the poll, we saw that you think that on-site printing will dominate in the future, but there was some other things are not really sure of if on-site or off-site will dominate. Mm-hmm. So we will see in the future.
So more or less the conclusion, selecting the crawler or a gantry system, it's very important that you have the printing location determined. So whether you will be printing on-site or off-site. And the robotic crawler is very useful and effective for printing one-story buildings and for printing them on-site or off-site. This is also a possibility. And for the gantry, we can conclude that this is a very efficient way of constructing houses for multi-story buildings or by means of modular construction, and by doing this off-site. And by this type of producing the housing projects, we think that you achieve the highest overall equipment effectiveness. And I hope that you now understand a bit better the way that we want to explain more about the importance of the overall equipment effectiveness. As what we think is important is that in the end, you achieve the fastest return of investment. And this is very important by doing this by taking the different factors into account and then selecting the right system that is right for you and for your company. So we're now going to move forward to the Q&A. We have a couple of minutes left for this webinar. So we'll be checking some of the questions that we have.
Yeah, I saw some questions about constructing the floor slabs, and also how to print or connect walls that are hoisted on place on site. For that, I want to suggest you to follow our free course on our library. We have free education of how to print concrete printing, and we have also our new design course available. And in this course, the construction of, for example, floor slabs, connections, insulation are explained. So if you have questions about, for example, also the structural system, the beams, how to make columns, for example, register on our library for the information.
Perfect. Let's see any more questions.
How do you connect different precast walls to a form house? Yeah, so the connection between the walls is done with the structural system that are built into the hollow walls. So we use like a conventional RC frame within our walls. Lifespan and maintenance, clean out. So the clean out of the robotic, we have our mixing pump system, and after stopping the system, it has to be cleaned out. So you have to clean the system and have to flush it with water, and after that you can do the startup again.
This is approximately 5 to 10 minutes, and we have to do this because we have a fast setting material between 3 to 5 minutes. So this is very important that we clean, for example, the hose and the mixing pump system immediately to prevent it from clogging. But this is only a process which takes about 5 minutes to do so.
I think that's maybe the last question because we have already on time. So how are the materials accessed in North America? Can you explain something about our local material development?
We have a power pack, which is basically the compound that is required to mix the materials locally. So then you would only require 30% of the power pack and 70% of your local materials. And we can take care of the testings here at our factory in the Netherlands to make sure that this is all workable with our printing materials. I think we have to say goodbye to you. Thank you very much for attending this webinar. And we hope that you will be joining our next webinar on the 25th of July. It will be a bit later because we will be talking with one of our partners in New Zealand. So he will be talking about his experiences in 3D concrete printing and basically all the things that he got through and what he's doing right now at the moment. So it would be very nice to have one of our partners telling their experiences. So this will be done in the next webinar. So make sure that you're subscribed to either our newsletter or be subscribed on the library. So you will be notified once we have a new webinar upcoming. So you can join this webinar. So thank you very much once again. If there are any other questions regarding any of our equipment, please feel free to send an email either to sales@cibapon.eu or contact us through the contact page on our website. And we will be happy to answer any of the remaining questions that you might have after this webinar. And we hope to see you again next month during our next webinar.
Yes. Thank you for your interest.
Thank you very much. And for a lot of people, have a great rest of the day. And otherwise, have a great evening. And we'll see each other soon.
Yes. Bye-bye.
Thank you very much. Bye-bye.